The first thing to do is sketch a graph and see what's going on here. So there's focus points at 0, 4 and 0, -4. And then y-intercepts at ±2. And then we could have the parabola, hyperbola, swinging like this and go through the two, or go at some angle. But it would be easiest to instead just have that be the vertex, and on this branch as well. So we'll use this. Now use the fact that the distance to the focus is c, so we've got c equals 4, and this distance is known as a, so a equals 2. And then we'll find b. So the general form for a hyperbola that opens on the y-axis is y squared divided by a squared minus x squared divided by b squared equals 1. And then we can also use the formula that c squared equals a squared plus b squared. This is very similar for the ellipse, except for the ellipse this would be positive and this would be subtract. So they're opposite. Okay, so the c is a 4 and the a is a 2. So this is going to be 4 squared equals 2 squared plus b squared. Subtract 4 from both sides and we've got b squared is equal to 12. And don't take the square root, because right here in the general formula we see that we use b squared, so just leave it as a 12. And this one, the way that I set it up, is centered at the origin, so I can use just y squared and x squared there, and then we're done. So y squared over a squared minus x squared over the b squared is equal to 1. And that's the equation. Well, that's one of the equations. That one works.